In this video, we're going to start talking about applications of linear equations, and we'll begin by talking about a general problem-solving strategy. So this strategy can be used to solve any kind of application, no matter if the equation that you're writing is linear or not. The first thing you want to do is read the problem. That also means understand the problem, understand everything that is being explained to you. You might need to write some things down, or maybe make a picture to understand it, or think about any experiences that you have that can relate to that problem to help you make sense of what's going on. You should next identify what you're trying to find. What is the question asking you to do? Usually it's one of the very last things in the text. Third, you'll write a variable and also any expressions that are needed to describe the quantities that you're looking for, the quantities that you have. And then you're going to translate those expressions into an equation. So you might have to look for some other information that's given, any relationship between the quantities in the text that tell you how to write your equation. Once you have your equation, then you'll solve it, and then use that solution. Check it for accuracy. You could use that algebraic method of going back and substituting that value in to see if it works out algebraically, but you should also check it for reasonableness. Does that answer make sense in the particular situation that you have? And then finally, it's not always the case where the solution to your equation answers the question, so just make sure that whatever question is posed to you, that you are answering that question and not just giving some value for some variable. So we're going to begin looking at some number problems. So we'll focus on kind of direct translation problems where we could almost directly translate the text from English to an equation, and then we'll look at some consecutive integer problems. The first problem reads, the sum of two numbers is -23. One number is 7 less than the other. Find the numbers. All right, so we're going to start by writing this out as best we can verbatim. So let me switch to my paper here. So the problem reads, the sum of two numbers, let me go back to it, the sum of two numbers is -23. So we have one number plus another, and that sum is -23. So I'm going to write that out kind of in words first. So one number plus another number equals -23, and then I'll show you what that looks like. All right, so one number plus another number equals -23. The sum of two numbers is -23. Now what we don't know is what these two numbers are. There are lots of numbers that can add up to -23. And if we just start making a list of them, we can kind of go on forever and ever. So we need to use some of the other information that is given. So what we also know is that one number is 7 less than the other. So if we know one number, let's say one number is x, let's say the one number is x, the other is 7 less than. So 7 less than means take 7 away. So if I have one number, so one number is x, I could just say one number equals x. The other, we said is 7, we were told is 7 less than that. So the other is that first number minus 7. 7 less than that number. So I can take these and substitute them in here and rewrite my equation. So some number x plus another number, which is x minus 7, is equal to -23. And now I could go ahead and solve that equation. So I'll combine like terms, 2x minus 7 equals -23. Isolate the variable, so I'll add 7 to both sides here. 2x equals negative 16, and then divide by 2. X equals negative 8. So that means that one of the numbers that I found is negative 8, and then the other number we found would be equal to negative 8 minus 7, and negative 8 minus 7 is negative 15. So let's go back and check what the question was asking us to find. The question said find the numbers, so I did find both of them. We found one of them to be negative 8 and the other one to be negative 15. So we could just write that in words. The numbers are negative 8 and negative 15. There we are. All right, let's take a look at the next question. Find 3 consecutive integers whose sum is negative 96. All right, so before we look at how to solve this question, let's talk about what it means to have consecutive integers. So consecutive just means one right after the other. Integers are, you can think of whole numbers, 0, 1, 2, 3, 4, 5, and then the negative of the positives, negative 1, negative 2. So integers are infinite in both directions. So we could think about numbers like, let's say, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and so forth. But I could go beyond negative 5 and go above positive 5 as well. So I'm looking for integers who add up, whose sum is negative 96. Now I don't know what they are. I need to find 3 numbers that go right in a row that add up to negative 96. In general, when you're looking for consecutive integers, we can start with the first one as our unknown. The first one we can write as x. So consecutive integers. So let's say the first one is x. Now if we think about an example of consecutive integers off to the side here, so if I start with 15, the next consecutive integer would be 16, and then 17, and then 18, and so forth. So if I have 1, I can get to the next one by adding 1. So if the first consecutive integer is x, that means the second is x plus 1. The third would be x plus 2, and so forth. And I would have x plus 3, x plus 4, x plus 5, depending on how many I needed. Now what we might also see is a question asking for consecutive even or consecutive odd integers. So let's take a look at an example of consecutive even integers. So I'm going to start with an even integer. Let's say I start with 8. The next even integer after 8 would be 10, and then I would have 12, 14, and so forth. If I had consecutive odd integers, let's say I start with an odd number like 13, the next odd integer would be 15, 17, 19, and so forth. The same thing happens if I have negative odd numbers. Let's say I have negative 9 as an odd number. The next one, the next highest one, would be negative 7, then negative 5, and then negative 3, and so forth. Notice that these are going up in value by 2. Here, these are going up in value by 2. Even the evens are going up in value by 2. So no matter whether or not my first number is odd or even, to get to the next consecutive even or the next consecutive odd number, I'm adding 2 every single time. So if I'm asked to find something out about consecutive even or odd integers, the first one is x, the second one is x plus 2, the third one would be x plus 4, and if I needed a fourth one, I'll squeeze that in here, that would be x plus 6. So again, no matter whether your first one is even or odd, they're always 2 apart. So the first one, let's say, is 8. The next one, add 2 to get 10. So to go from the first one to the third one, you would add 4, x plus 4. To get from the first one to the fourth one, you would add 6, x plus 6. Right? All of these go back to that first number. Even if you have an odd beginning number, the next consecutive odd, you continue to add 2. So my first one is 13. The next one would be 15. Add 2. The third one is 4 more than the first one. The fourth one is 6 more than the first one. That's this expression here. So we're going to use that in the next 2 examples. So for example 2, we're finding 3 consecutive integers whose sum is negative 96. So we want the sum, write that down. So sum negative 96, and we want 3 consecutive integers. Okay, so if I have, pull this down here, if I'm looking for 3 consecutive integers, my first one will be x, the second, x plus 1, the third, x plus 2. It really does pay to write that off to the side because that will help you when you're going back to answer the question as well. And we're told the sum should be negative 96. So sum means I'm adding, so I want to add these 3 numbers together. Now, that helps me write my equation. X plus the second one, x plus 1, plus the third one, x plus 2, equals negative 96. So now I could take that equation and solve it. X plus x is 3x. 1 plus 2 is 3. And that equals negative 96. And then continue to solve. So subtract 3 from both sides. 3x equals negative 99. Divide by 3. X equals negative 33. All right, so let's see, what was the question asking? Was it asking for, all right, find 3 integers. So I want to find all 3 of them. I found the first one. Okay, the first one is negative 33. The second one is 1 higher, so that's negative 32. The third one is 2 higher, that's negative 31. So if I wanted to check this, I could just take these 3 numbers, negative 33, negative 32, negative 31, add them together, and I should have negative 96. And that does work, so you can check that. All right, let's take a look at the next example. Here we're looking for 3 consecutive even integers whose sum is 102. So here I want my sum to be 102, and I'm looking for 3 consecutive even integers. So if I'm looking for 3 consecutive even integers, my first is x. Because I'm looking at even integers, I'm going to skip 1, so the second is x plus 2. The third would be x plus 4. All right, and I know the sum is 102, which I wrote down here. So I'm taking these 3, adding them together, x plus 2, plus x plus 4 equals 102. Combining like terms, I have 3x plus 6 equals 102, and then begin to subtract. 3x equals, so 102 minus 6 is going to give me 96, and then divide by 3 on both sides. X is equal to 32. Okay, so now here, remember I wanted consecutive even, so it makes sense that my answer is even. So again, I said check for reasonableness. That answer is reasonable. So my first is 32. My next one would be 34. And then the last one would be 36.